Can you guys see my screen right now?
Yep.
Thank you. So it was not like required, but I asked student to turn on the camera on Tuesday, and then I
Mhm.
think only like four, two
Mhm.
or four student they turn on. Oh yeah, Ray and then Sarah. I remember the face. So it was interesting because like I think most of them are not familiar with Jupyter Notebook. I don't so yeah, that was kind of different
Mm.
from last year. Oh,
Yes, in the orientation, and then I told the
ah,
student, maybe we need to
uh,
know the Jupyter, and then
mm,
you know, uh, s- Jupyter is not that difficult, so definitely, and then it's a matter of mm, yes, so
yeah,
please, student, and then try Jupyter, and it
yeah.
can way, uh, make your life, really, really easier.
Um, yeah, I'm gonna drop my email at the end of the session. So if you guys have any questions, just mail me. Actually, I can share right now. And also, Jaden, it's fine. You can just like drop a message in the chat if you have an issue with your computer. Um,
Yeah, I think you can start now. Yeah. Mm. Right.
okay,
Please. Yep.
so we learned basics, the Python basics on Tuesday. Hope you guys remember some of the components we went over together. We learned what is programming and why we had to learn that some data structures and the function and the for loop, while loop. So those like a basics the things we learned. It's gonna be very helpful today's session. So, um, and then today's session is going to be like data analysis, and then we're gonna learn some Python libraries, and then learn how we're gonna do like a fancy visualization with those libraries, and then how to uh, um, play with the data, how to process the data, how to read the data, and also how to interpret the data through visualization. Okay, so we're gonna learn Python library, and then as a part of that, we're gonna learn how to read a file, for example, like a CSV file, and then how we're gonna read the data, how we're gonna process the data, and also we're gonna code something. We're gonna learn something called data frame, and also some simple like graphics. So there are some popular Python libraries, NumPy, SciPy, Pandas, and Skitlearn, and some visualization libraries. It's called Matplot library and the Seaborn. And then I think in the next week's session, you guys are gonna learn or get more opportunities to work with this library. But before that, let's talk about what is the library and why we have to use them, okay? Um, does anyone here or is anybody like familiar with the term library here? Do you guys know what is that? Okay, that's great. So I in the last class I mentioned that writing a good code and having a good naming is very important, right? And because usually you share the code, and then if you write a good code, good function, you can share the code with somebody, and then they can use that function, right? So library is some kind of set of the function someone already wrote before, and then you can easily use the library in the Python. So those are all the libraries already implemented before, and then NumPy is one of them, very famous. And then this is for high dimensional list or arrays or matrices, and then it helps you to do some kind of complex calculation better and the more efficiently. And also there are like some kind of operation it provided we can use, and many of the Python library is actually built on NumPy. So NumPy is very like widely used across multiple libraries. Maybe you don't even know if you're using NumPy or not because they're using under the hood. And another one is SciPy. It helps you to do some like a fancy work with some fancy algorithm like linear algebra or complex equations or some kind of optimization or like statistics, like getting like average or like a p-value or some other like statistical method you can use with SciPy. And also this is also built on top of built on NumPy. Next is pandas. You can think about, are you guys familiar with Panda library? Have you guys used that before? Okay. Okay, so you can think about you guys have an Excel file and there are a lot of like data, and then it has a column and row, but sometimes you wanna like manipulate the data, like you wanna copy or paste, and you wanna like append the data next to each other, or you wanna get like some of the like values in the same column, and then all of these things you can do with the pandas because it will help you to load the data and then adding the columns together or calculate the average or merging, sorting, or slicing. So every this kind of like data manipulation stuff you can do with the pandas. And then for the data structure, Panda use with the Python called data frames and or series, and then we're gonna learn that later during the demo. And another one, scikit-learn is provide machine learning algorithm like classification, regression, clustering, or validation. It also built on NumPy and SciPy and Matplotlib library. And then Matplotlib library is used here to provide some kind of visualization tool. And you're gonna learn machine learning next week. So we get a more chance to use this library in next week. So yeah, these are Matplotlib library. I just explained visualization library. It can help you to draw different charts like line plots, scatter plot, bar chart, histograms. So all kinds of different chart you can draw with the Matplotlib library. And Seaborn, this is also part of the visualization library. It also have some kind of different visualization. You can do some kind of fancy graphics, like statistical graphics. You're not gonna use this a lot this class, but this is very, very popular too. So now we are talking about different libraries, then you might wonder that how am I using the library, right? So in the Jupyter notebook, you can use kind of call this library by using this import keyword. So you can think of Jupyter's already have some kind of libraries ready in the back, but you don't see it. But if you want to use those library, you can just use import and then using the name of the library. So here, import NumPy, import SciPy, or import Panda. And if you run this code, then the Jupyter Notebook will load all the functions. So you can use a function if you want. But sometimes the library name is too long. So you can use some kind of alias called this AS. And then, for example, you want to call NumPy as NP, or you can call SciPy as SP. So once you define alias, you can use that instead of using the full library names. So this is how you load the libraries. And then you might want to read some files because most of the data is stored in a file format. So here you can use pandas. So here you can see you use the alias of pandas PD, and then if you use dot, and then that means you can you want to run specific function a part of the pandas library, and then they support this function called read underscore CSV. And then if you put a file name in double quote like this, that means, okay, Python, I want to read the salaries.csv file using this panda library, and I'm going to call read underscore CSV function, right? So in this demo, we're gonna load a CSV file, and then we're gonna work with that data. But they support other functions too, like you can read Excel file, or you can use SAS file. Those are also kind of different file format used widely in academia area or some for the research. So they support different functions to work with the different file formats. But CSV is the simplest format to work with, so that's why we're going to use CSV today. And if you want to read like a top 5 records in the data file, you can just use a df.head function, and then if you do that, it's gonna load top 5 rows in that CSV file. So the data set we're gonna work with today, it's kind of sample data set, have a different columns like a rank, a discipline, a PhD, service, sex, or salary. So we can just focus on like rank and then salary today or sex, and then we're gonna work with, okay, with this data, how we're gonna get some insights, right? That's our goal today. So there is a way we can read the data, not just 5 rows, 10, 20, 50 records, and then I'm going to show you later. And then to like the last few records, there is also a function to do that. And let's see. Okay, so I explained what is the libraries, and then I said library is a collection of the code. It's already written by some developers or someone else to implement the specific functions. So you don't need to write a code at all. You can just call the function. And then, so this is Jupyter Notebook. And then you don't need to like add any like files here because they will help you to load the libraries if you want. So what you just need to do is use import, and they use a library name, and they put the alias in here, and then just run this cell, and then you see the green check mark. That means there was no error. It load the libraries correctly in this Jupyter Notebook. So you're good to use these libraries. So for example, if you do np dot, it's gonna show you the functions you can use. And if you can see the list of the function, that means they load this function, they load this library correctly. But let's say you didn't load anything, but you wanna like do something like here, maybe it will show up, but you will not see the list of the function you can use because it's not a library, okay? So, and then we ran the cell, so everything is fine. And then if you guys remember the list, you can create a list in this way, put the number or strings or different type of the data in this square bracket. And then how you can do it, you put 1, 2, 3, 4, 5, and then you can see this is the list of the data by running this cell. And then if you want to use NumPy, and this is the way you can create a list that NumPy understand. For example, if you call this np dot array, and if you put the list format inside of this as parameter, it's gonna create NumPy version of list for you. So for example, this one and this one look same, but if you can see that they call the specific function like np dot array, and then it put the list inside of here. You can also use a variable if you wanna, if you already define the list before like this, but it's like depending on like how you wanna test with this function. And then if you print it out, you're gonna see the same format here, but they're like different type. This is a Python built-in list, and this is a NumPy array or list. You defined using NumPy library. So when you use a type function, do you guys remember type, a built-in function we used on Tuesday? Just kind of show you what kind of type of the variable you're using, right? So if you use the type and then put the variable name in here, it's gonna show you, okay, this type is not a list. This is a NumPy that ND array. So this is a NumPy, this is array, which is part of the NumPy. So that's how you create a list. So this is how you work with the library and also import the library. So going back to the slide. So for the data frame, they also have different type of different types for the pandas. So like Python, we had a string, int, float, but they have something different. String is object or int is int, but they put like 64 there and the float 64. They're like basically similar, but because they have different like rules, so for the pandas, they have different type they use. So going back, let's work with some NumPy more. So if you guys remember the for loop we learned on Tuesday, it helps you to get one element at a time. So if you use element, and then if you have a list of numbers after this in keyword, it's gonna pop one value at a time. So first element is gonna be 1, 2, next 2, next 3, next 4, and next 5. And what you can do here, you wanna find a count. So count is here, which is going to be an index. So you wanna add the value, add 5 to each element. So here what you can see that is for the first 0 index of the value, you wanna add 5. And then you add the 1 to the count. So you're going into the next index, which is going to be 1. So you're gonna eventually add 5 to each element. So if you run this, you can see that, okay, this is a number of the list, and then this is the after you add 5 to each element. So, however, okay, this is showing plus 10 because we ran two line at a same time. Wait. Oh. Let me see. Yeah, however, but you can think of this like adding 5, and I think you already add 5 here, so that's why it's showing the number here. So if you do just list numbers, it's gonna show you the correct result. However, if you wanna make this into one line, like in a fancy way, we call it list comprehensions. So you can just using the one line, like doing some kind of addition here. So what does it mean by you just need to use the same thing in here, and then you just need to add a statement. And then if you like wrap it with the square bracket, it's gonna run this statement one by one. So basically, it's going to be the same as this line. So when you see this value, it's going to be 11 because you're adding 5 here. You're adding another 5 here. So the total, they added 10 to each element. And then it's going to be 11, 12, 13, 14, 15. However, we can do the same thing with the NumPy. But to do that, you just need to just wrap this list with an np.array. And then instead of like adding like 5 to each element or using the for loop, you can just do this. So this is really convenient because you don't need to add 5 to each element. If you just do plus 5 to the NP array, they're gonna add 5 to all of these elements. So it's gonna simplify your simplify your code when you wanna do mathematical operations or do some like a math with the list. So if you wanna do, you can just do 10 to. It's gonna be just add 10 to each element. I think you can do multiplication as well. So this is very neat and I think it's very cool. Yeah, next. So do you guys remember slicing an index? If we wanted to get some specific range in the list, we use the slicing, right? I think we have to clear all the let me see. Clear all outputs. Okay. If you guys remember, do you know what is gonna return if you do slices list? This is from 1 to 4. So this means starting from index 1 to 4, but for index 4 value is not included. So it's going to be 1, 2, 3, 4, but 4 is not included, so it's gonna be 2, 3, 4, right? Ooh, that was close, but it's fine because the index is starting from 0. In this programming world, it's very weird because we never count from the 0. Yeah, but if you want to make that, how can you do this? Let's say we want to print out from 1 to 3. How can you change this to print 1, 2, 3? Okay, let's try it. It's very interesting, right? If there is an index 0 included, it's very tricky. So I think there is a tip. If you so end index minus starting index is gonna be the number of element you can get. So for example, this one, our index is 2 and the starting index is 0. So if you do 2 minus 0, that's 2, right? So you can think of it's gonna return 2 elements starting from the 0. So it's gonna be 1, 2. So if you wanna print out 3 elements, you can just change it to 3. So that means you wanna print out three number of elements starting from 0, but 3 is not included. But you know it's 3 elements because you can just use the index, like end index and starting index, and just minus it, and then you will get the number of the total elements you can get using this range. And I also showed you a little bit. You can remove this 0 because Python will understand, okay, you didn't put any index, starting index, then they're just gonna start from the 0 automatically. Yeah, good job. So going next, we can do the same thing with NumPy array. Everything is same, but just this part is different. You're using np the array, put the index, and then everything's gonna be just same, just like using the normal list. So this is also fun examples. If you wanna add the two arrays, right? Let's say you wanna add 1, 4, and then 2, 5, and then you wanna add 3, 6. So you wanna add the element in the same at the same index between the two lists. And then to do that, how are you gonna write a function, right? So to do that, you will have to go through each element for some list and then get the index of it, right? Let's say you wanna start from the 0 index and then add them together, and add them together. And then you can do that with this for loop, right? So let's say you have empty result. You don't have anything in this list yet, but you're gonna add the result to this empty list, okay? So what you can do here, if you do length, it's gonna give you like a length of the list, right? So length here is gonna be 3. So somehow if you use range, that means, okay, I'm gonna get the range value starting from the 0 and 3, but 3 is not included. So it's gonna be 0, 1, 2, and then you can access the value using that I variable. So it's gonna be list 1, 0, list 2, 0, and then you're gonna add that. And then using the append function, you can add the value to the result. So this result's gonna show you 5, 7, 9. Okay, so if you wanna do minus list 1 from list 1 to list 2, what do we need to change here? Let's see. It's pretty straight. Yeah, operator, right? So if we change plus to minus, it's gonna give you -3, -3, -3, because they're like removing one list 1 minus list 2, right? And then if you change the position, this will gonna give you different result too. So you can work with the two different lists and then adding two arrays, or doing some like different operations. So we can do this too with the np numpy array. So instead of like accessing the element one by one, what you can do is just to plus. So here, if you do this, it's just gonna like apply the addition, and you don't need to do anything. You don't need to go through all the elements. You just need to, they're just gonna plus doing the addition from array 1 to array 2. And then if you wanna do minus, you can also change it, and then they're gonna do the same thing. So it's very makes it very simple, right? So you don't need to understand all of this code. I just wanted to give you like a fun demo. So now you might wonder why we have to learn NumPy, right? So you understand, okay, this is gonna give you a result and it makes code simpler, but is it really good, right? You might be curious. So what we can do, what we're gonna do here, we're gonna load the image. But we're gonna load the image just using the list, okay? This is complicated, so you don't need to understand everything, but just remember we are reading the image one by one to the list, okay? So image is consist of numbers. So you can also use the list to read the number and then you can visualize it. So for example, if you run this code, it's gonna show you anger. Are you guys familiar with this anger? Did you guys watch a movie animation? Yeah. So anger is my favorite character because it kind of looks similar to me when I'm really mad. And then I'm showing these images a lot of times. And then what we did here, we just load these images. So these images is called images.jpg. And then if you see the left panel, you can see images.jpg, which is I uploaded before. So if you click it, you can see the images before, right? And then if you want to use this image, what you can do, use the image library and then open it and then load the data and then show the image, right? And then what I did here is I wanted to see how long did it take to load this image to the list, right? So time to load the images was 0.01 second, which is not that bad, right? But can you do this with NumPy? I think we can do, right? Everything we can do with the list, we can do with NumPy as well. So this is exactly the same code, but only the difference is you're loading that image data using NumPy array. Do you think it's gonna be faster or gonna be slower? So we'll figure out. So let's run it and reload the same image. But you can see 0.001 second compared to 0.01. This is very like fast. So what we can interpret this how we can interpret this here is now like loading the small data, you can see the big difference. But in real world, you're loading like hundred of the data. The data is gigabytes, very big. For example, think about Instagram. You guys always checking images, someone's photo all the time, and they think about the computer have to process that images every day. It's gonna be a lot of images, right? Even we take a lot of pictures every day. So if you wanna save the images and optimize the process, saving, loading, processing, we'll have to find a way to optimize that process in programming. And then what we can do is using this NumPy library, right? So that's why this NumPy is used widely um, for the programming. Okay, so pandas. So I said Panda has special data structure called data frame. And you can just think of data frame is like a table. So it has row and it has columns. So row is like a horizontal line in your table. And then each row represent a different items or record. And then columns is like a vertical lines. And they have contains a specific type of information through across all items. Sometimes they have headers too. For example, let's say you have a friend's information table. You have headers here, name, age, and grade. And then in the same column, they're like storing the same type of the data, right? So in the name column, you have name, Emma, Bob, like Charlie or David, or under the age column, you have age value, and the grade, you have the grade here. And each record, like horizontal line, it represents one person's data, right? So this is Emma's record, and this is Bob's record, and this is Charlie, and this is David. And this is how we work with the table. And I'm going to show you how we can create this data using Python and pandas. So this is a dictionary, if you recall, and this is the key. Name is the key, and then I'm gonna store Emma, Bob, Charlie, David, so I can store the data in the list. And then there's age and the grade, and then you use pd.data frame, and then just put the data as a parameter. And if you print it out, it's gonna show you exactly the same table format that you're looking for. So you can see the name showing up in the header, age, a grade, and then the values are stored in each column. So this is how you can create a table with a data frame. Okay. So if I wanna add, let's say I wanna add one more row, and I wanna add maybe Ray, age, maybe, I don't know, maybe we can just put like 15. I'm just putting the random value, and then let's say grade is 8, right? If you want to put this value on top of add this row to this table, can you think of how we can change this existing data dictionary? Oh yeah, great. So you just need to add Ray here, and then add 15, and then into grade, and then we can run it. Yeah, and then we just added a one row on top of the existing table data. So this is how we can work with the table and then data frame. And then now let's say I just want to get the data under a name column, right? I don't need a lot of data. I just want to get the names, right? Then how you can do it, we store the data into df variable. And then what you can do is just put the column name inside of the square bracket. And if you run it, it will only show you the name values, right? Like Emma, Bob, Charlie, David, Ray. So this is how you can select a specific column. And if you want to get specific row, you can use iLoc. This is like an index location. So if you want to get just the first row of the value, you can, it's confusing, but the index starting with 0, so you can just run it, and it's going to show you the Emma's data, right? Emma's data here, so starting with the 0 index. So this is some kind of cheat sheet, like when we want to work with the data frame. They have the types. We saw the examples. There's object type, int type, also float. We saw that, and then we can also get the columns, and then index and the values. And if you want to get the 5 top rows, you can use head. If you want to get just a 5 last rows, you can use a tail. And this is how you can use it with the data frame. So we already have answers here. Think about with this attribute, how we can get the answers for these questions. I'll give you 1 to 2 minutes. Just think about how we can work with this data frame, get these answers. Also, if you have this parenthesis, that means you're calling functions. So you might want to put some parameters inside of here, or sometimes you can put it empty. That's depending on how did they design the functions. Some function, it can be empty, but some function, you have to put some values. You have to pass that value as parameter in the function. And these are some kind of variable is already defined in that in that library. So you don't need to call it like a function. If you do df dot d types, that's gonna give you an answer. It's not a function. It's kind of like you're accessing the variables in that data frame. It's already predefined. So going to um, the answers part. So this is how I use it. So number of record or rows in the data frame, you can just use length function. So then now we have 5 records, and then it's gonna give you 5. And then if you wanna get the size of the element, so the elements means if you go back here, we have 1, 2, 3. Each you can think of the cell as element, right? So Emma 12A, they're like considered as individual element. So we have like a 5 column, 3 no 5 row, 3 columns. So 5 multiplied by 3, it's gonna be 15. So that's why I show you 15. And if you want to get some column names, you can use the columns property and the df.columns and toList, and then it's gonna convert the columns value to the list, and then gonna show you the list type of the data here. And then if you want to get the type, you just need to do d type, and then it will show you, okay, name column is object type of the data, and age column is going to be int, grade is object. So if you want to get some information of the data, you can use this kind of functions or attributes. Okay, so some useful functions. Let's say you want to get some summary of your data frame, you can use info function. And if you want to get some like overview of the data, like with the numbers, and then you can use describe function. If you get a mean of the values, you can use the min function. You can also add up all the values together. You can use sum function, and then you can group the data by some specific column or some specific type. You can use group by. And then if you want to sort the values, which means you want to put the values in order. For example, data is like a mix together, and if you want to get the value like ascending order or descending order, you can use sort values function. And then if you want to remove some values, you can use drop function. And then there's going to be empty values sometimes. Most of the times, not all the values are existing in the data set. A lot of columns, a lot of values for the columns or for the row are missing. Then you can fill that empty places with fill NA 0. So how do you use it? Example, if you just do df the info, it's gonna show you information, summary, and describe. Same, it's just function. But if you wanna do group by, you can provide a specific column name that you wanna group together, and then this time you can use grade, and then you can also get means. So that means they're gonna group the data based on the grade and then get the mean value in the same group. And you can also sort values. And if you want to sort the table data by age, you can pass the age and then make sure this is the also you don't need to use it, but you can also use it kind of explicitly saying that this is the by parameter I'm gonna use, and then it's gonna be age, and then you can drop values as well, and then you can also do I want to fill the missing value with 0, and then you can just use this function in this way. Okay, so trees, well, we can solve it together. So let's see if you do df to describe what is the result. So you can see that for age column, they said, oh, you have 5 data, and the mean is 13, and the standard deviation is 1, and then mean value is 12, and max is 15. And then for 25% of the standard deviation, it's going to be 12, 13, 14. And then let's see how it looks like here. I think we should have to print this again for a better okay. Ooh, okay, I don't want to show just the first row. I want to see the whole data. Okay. Okay. So as you can see, we had the 5 data. And then the reason it only give you summary of the age column, because when you do describe, they only give you summary for the integer or float values. They don't do that by default for the string values. So there is a specific way if you want to get the summary of all of these values. So here they say, okay, mean value of this is 13, and the smallest value is 12, and the max is 15. So it kind of give you like overview what kind of data you have for this column. So sometimes you can think of, okay, I have a data, but mean is 12 or max is 15. So that's good. I have 5 data. So you can get some ideas what kind of data you have or you work with, right? And then you can also get the standard deviation with this std function. Now age have standard deviation 1.3. That means they're like far from each other, like 1.3 amount in general. And then you can also get 3 top data using the age under the age column, and then you can work with it too. So mean value of the first 3 records is going to be 12.33. And then if you want to filter, you can also filter the data. You want to get the data under age column bigger than 12, and you can use this. And how it's going to give you a result. All the data is going to be going to have age value bigger than 12. So you can also filter the data if you want. And to read the data into a Panda data frame, you can just do like this. And then this is a salaries data, and then you read the data, and then you just show the 5 top records here. Okay, so it's 7:50 right now. We're gonna have a 10 minutes break, and then we're gonna meet again at 8 p.m. Hey, can you guys hear me loud and clear? Okay, great. So you're halfway done. Nice. Thank you, Jaden. So let's play with more sample data set. So we can read salaries.csv data. How does it look like? You can also look at the data in Jupyter Notebook, Colab. Here you can see there are a lot of data sets a lot of rows and columns. So this is fake data, but somehow you can see that something is very um kind of interesting. Um, so yeah, let's work with this data. So remove this for now. All right, so if you want to write a data to CSV file, there is also a cool function called to underscore the CSV. And then if you just run it, yeah, here, you can also write the current data frame into the test CSV file if you want. So this is also cool function, can be very handy if you want to write something in the CSV file. So and then reading the data, writing a CSV file, and then going into before we work with that data set, going over the matplotlib library real quick. So this is a Python library. You can create a interactive visualization dashboard or show the chart. And then the way you can use the matplotlib library is something like this. So you have a matplotlib library already imported, but you can import the specific set of a library using the dot. So you want to use pyplot, and then you want to name it plt. So you have x column data 1 2 3 4 5, y 2 3 5 6 11. So you can just plot it using the plot function, put x and y data, and then if you run it, it's gonna show you like this. So 1 2 3 4 5 is represented on x-axis, and then y value is going to be here. So it's like a pair of the value. You can think 1 2 is going to be 1 2 here, this dot, and then it's going to be 2 3, and then you have a 2 3 here. And then what they do is connecting all the dots together, so they're making the line plot. And then this is one example how you can draw the line with this x-axis, y-axis data. And you can also do the bar chart. You have some kind of X data, you can call it categories, and apple, banana, cherries, and then the value you have 5 apple, 3 bananas, 8 cherries, and dates. And then if you call the bar function, it will also show you the bar chart, and then you can put the title as well. You can put the title simple bar plot, and it's gonna show up on the top. And then you can put the X label fruits, so it's gonna be fruits here. And then the Y column is quantity. So this is how you can customize the chart with the specific title and label values. And then you can also draw the scatter plot. And then here, x and y are same, but you call the different function scatter. And then instead of drawing the line or making it into the bar, it's gonna just show the like a dot for the specific points like x, y. So you can see where they're located in this in this chart. So this is a basic chart you can play with using the data set, and it's gonna be really useful if you wanna, if there are like a lot of data, you wanna see where they're located, what is the relationship between them. So using the chart a lot, then it will give you some like insight. And yeah, this is the how you use library to visualize data. And then going back to the slide. Okay, we covered it. You can get the mean value and others in the rank. And this is the sample data I talked about. And this is how we read the data set. And then the data set will look like this. And then to get the top 10 rows, you can put 10 here. And it's gonna show you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see the same values here. If you wanna explore the data, use the describe function. And then you have like integer or float type of the column, PhD, service, salary, and then it's gonna give you overview. Like, okay, you have 78 of data, the rows, so that's why they're all same. And then they're gonna give you, okay, mean value for the PhD data is 19, I guess this year, and the service is also 15. And the salary is around 108K, and then standard deviation, what is the mean value, and then our max value. So you can kind of say, okay, the data I have, the average of the PhD years is 19, and the service is 12, services are 15. So you can kind of imagine how your data is distributed and then how the data look like. Then you can also get the size and shape. So if you do size, it's gonna be all the elements like 1, 2, 3, 4, 5, 6 like that, and it's gonna give you have like total of 468 elements. And then if you wanna do just get the table row column size, it's gonna show you, okay, you have 78 row and the 6 column, which means we have 1, 2, 3, 4, 5, 6 here, and then you have like 78 rows. And then if you wanna see the last few records, you can also use tail. And if you go to page 8 here on the right panel, you can see the last 5 rows are matching with this output result. Right? I think it's correct or different. I think it's same. Oh, I sorted by clicking this arrow sign, so that's why it's different. But the original data set have this data structure. So moving forward, you can also get the types of the data, and you can also get the what is the salary column type, and then it's gonna show you int 64, and you can get all the all different types across the columns. And if you just do df the d types, it's gonna show you the type for each column. And then you can also get the columns name. It's gonna go, okay, you have these columns for the data. And you can get what is a column name, and then rows, and then it's gonna show you, okay, your column has these values and their object, and also it start from the 0 to 78, so you can kind of get some idea of it as well. Yeah, so these are all useful function. Dimension, it has 2 dimension because row and column, so that's why it return a number of dimension is 2, because it's a 2-dimensional array. And you can get the size I showed you earlier, and also get the shape, and also get the values if you want like this. Okay. So next, we saw we can also group the data by specific column. So let's say we wanna group the data by rank. So you can call group by function and then put the rank here. And if you print it out, you can see that for the rank, rank is professor, assist professor, and associate professor. And then you can see that, okay, same rank, for the same rank data, you can see all the data set under the same rank. So this is same rank values and then all the associated data. And then if the second group is assist professor, and then they also have their own data in group. And then if you just have a professor, and then you're gonna see the data set in the same group. You can also show this data by maybe gender or sex, and then you can just run it, and then they're gonna show you, okay, in female data, for female, there are like this kind of data we have, and then there are also like a male professor information here. So if you wanna grouping the data by specific value, you can use group by function. Okay, so if you want to filter the data, okay, I want to get the data which has a salary is more than 120K. You can use this operator, and then if you do that, it's gonna give you the result of which satisfy this statement. And then this statement, if you just use this statement, it's not gonna show you anything, because this one itself is just a statement. So if you want to get a result and apply this statement to this data set, you will have to put this variable here. So this is gonna be saved into df underscore sub. And then if you wanna get the 5 top records, you can just use it like that. What if I wanna get the data, the salary is smaller than 100K and bigger than 10K? Do you think we can do that? So I think first we'll have to change this to a smaller than 120, right? 120K, because we want to get the value smaller than 120K. Can you do like this? Let's try out. Okay. It says it's not working because they wouldn't understand. They basically say, okay, I don't understand this. So another way is maybe we will have to provide them like two separate statement, right? What we can do is we can do salary filter 1, and maybe we can create another filter which is going to be smaller than let's say 100K, and then we can apply this. And then now we are still seeing some data, but we can apply this 2 times, for example. So after you apply the filter 1, and then you can apply the filter 2, and then save the data, and then you can do like this. And in this way, you can apply different filters 2 times, or I think you can do this too as well. Let's try it out. Right. So you can use this AND operator, which means I want to filter the data satisfying this filter and this filter, right? To simplify this, you can also connect this with this like that. So what does it mean is, oh, it's not working. Why? Interesting. But usually if you use the two filter like this, you can always connect this filter. Oh, I think it's a two when you connect it. But if you want to connect them, you can use this AND operator, and then you can filter multiple things at within a one line. So this is a higher filter with multiple conditions. And also, you can also search for a specific value. For example, if you want to find the female professors, you can do this filter inside of this square bracket and say, oh, I want this column value has a female in it. And then if you run it, you're gonna see all the records has a female value in this column. So you can search that in the table as well. You can also get specific columns of the data. If you remember in the list, we used some number to slice with the column. And then for the data frame, you can use this specific column as a list in the list, and they get the specific data like this. So this means I only need rank and salary column and those data, and I don't need other columns, right? So it only show you rank and salary here. You can also get the specific value, and they get the columns and they get the mean here. So this is how you use like different functions. And then if you want to work with it more, you can also get the max. And here, because alphabet, it's like a alphabetical order. When you do max, the B is bigger than A because A comes first. So that's why it shows B here. And then it's gonna, for the number, it's gonna show you the max value as expected. And also, yeah, also the salary, it's gonna be all like highest value. And then if you wanna get the max value for specific column, you can also run it like that. And for mean value, like these are all like same. You just need to remember what function you have to use. And you can also get the count of the total like row for specific column. And then you can also drop all the record have a missing value. And then if you want to get specific rows, there is a way you can do that too. For a column, you can put the column names in the list. But if you want to get the specific row, you can do the same. This is from 10 to 20. And then now you can say how many rows is going to return, right? I gave you some kind of a way to calculate how many rows it's going to return when we using the index. So here it's going to be from 10, starting from 10 and 20. But 20 the data at index 20 not included. So it's going to be 20 minus 10. So 10 rows of the data are going to be returned, including 10 to 19. And if you want to get the specific index of the row data, you can just use 0 and then -1. Do you guys remember how do we use -1 for the list, in the list? No? So for example, let's add the code, list data, list data, anyone remember what -1 index is gonna return? I said we start from 0 and the minus is going backward. So this case, starting from 0, it go -1, so it's going back and then returning 4, like this. And then you could also do -2, but if you do 0, it's gonna starting from the beginning. So it's the same for the data frame, but the function is different. You have to use ilog, index location, and then you can do 0 and -1, that they're gonna, instead of using the list, we use the table data structure. And if you do -1, it's gonna return the last row. And then if you do 0, it's gonna be first row. And then if you wanna use some kind of index, both for the columns and rows, you can use the rows information. So row index is coming first, and then comma means there's gonna be column information comes after. So this is rows and columns. So for example, if you do like this, you can see that the data index starting from 10 to 20 is gonna give you the rows, and then you get specific columns, rank, sex, salary. So this is how you can filter the data using the data frame. And then you can also sort values if you want. If you want to sort values by service or salary, you can also do using the sort underscore values, and then you can see service starting from 0. And then if there are like a two same value in the service, and then it compare the salary values. Because services come first, they sort the value with service first, and then if they have the same value in the service, they're gonna give you another result sorted in by salary column. So if you can see that the service have a same value, but the salary are different, so it's giving you the smallest value first in the salary, and that they are coming as a first row. And then you can get only 20 value here. And if you wanna get a service value, the bigger value first, and then if you wanna see the salary value after you sort the service in a descending order, and if you wanna do salary ascending order, you can also do in this way. That means for a service, you wanna see the value biggest, smallest first, and then for the same value, if there's any smallest value, I wanna see salary, which is bigger value first. So if you run this, you can see the service value are same for these records, but you can see among the records having a same service value, you can see the highest salary here, right? So this is how you use how you can sort data. If also we can handle missing values. So for the salary CSV data, there is no missing value. But we can check another data set, flight CSV. This is very, very big data. And then if you look at it, some values are missing. And then if you load it, you can see like different columns of the data as well. And then you can check, okay, I want to see the data, missing data, and then filter them, right? And what you can do is you can select the rows have at least one missing value. So you get all the rows data, and then this is some kind of filter, and then you get the this flight data. And then what you can do, if you do, this is the all the data missing any value. So you can see there, this data has no value, and then this is represented as NaN, and then you can see that there are a lot of data doesn't have a value in this record, and then we got this data. And then if we use ACES and 1, it means it's looking across. So it's gonna give you just, oh, this record 0 doesn't have any missing data or blah, blah, blah. But if you wanna do like a column wise, we can also say, okay, year column doesn't have any missing data. However, department time, department delay, they have missing data. So you can also get some idea. Okay, I have big data, but I want to see which data is missing. Then you can run this function to see. Okay, year data I have like complete data, but maybe department time or arrival time I don't have it. So you can look into it and then work with the data set, making sure that data is valid, and then you don't the data is not biased. So that's how you can work with this data frame. So this is all the things I cover, so I will skip this. This is checking is this missing data or is not missing. If it's missing, I wanna like fill in with 0. I wanna drop the rows that contain less than 5. So this all can be useful if you wanna work with data with a specific condition. You can also get mean, max, count, sum, median, standard deviation, and then this is also aggregation. What I mean by that is you can get some kind of aggregated data for a mean, smallest, mean, and max value. Then you can say, okay, I want to get the mean, and max for the salary column. Then you can just use aggregate AGG, and then mean using the function name here, and then it will show you, okay, for all the records on the salary column, the mean is like this or max is like this. And if you sometimes get confused by the function, you can just put the mouse here, hover your mouse on top of the function, and it's gonna give you some kind of examples like, oh, this function aggregate using one or more operations over the specified ACES. So parameters is going to be some kind of name, and then you can also scroll down, reading some information. So usually sometimes it's helpful if you want to get some like information on how to use this function. And then another one is I said if you use describe, it gives you overview of integer type of the data set. But if you want to get an overview of object data as well, then you can include O. I believe this O stands for object. And then now they're giving you overview for the object data. For example, the carrier, tail number, origin, destination. So instead of giving you overview for the numbers, it's like a string value. For example, it can be a flight carrier, so like a Delta or like Alaska, or so origin is going to be maybe LA, and the destination can be I don't know, Irvine. So like it depends on how do they have the data, right? So yeah, and then they said top is UA, and then tail number, I think this is a flight number, and the origin is LGA, which means LGA origin airport showed up the most in this data set. So you can also get some summary for object type of the data. So these are all some kind of useful functions. I'm pretty sure you all have this file, so I recommend to play with all of this code. If you want to see skewness of the data, which means you want to see how tilted of this data, or you can also draw it with the plot library, and you can see that, okay, I'm seeing the data chart, and the most of the data is kind of tilted to the left, and then it kind of give you an overview. Okay, this is distribution of the data I have, so it can be also very, very helpful when you're working with big data. So we just have like a visualization part left. So I'll just go back to the slide, making sure we cover every slide that I prepared. So yeah, this is how we use a group by, and then you put the column name here. And then if you wanna get the mean value, you can also put so this is a group by, and then for all the data under the same rank, you want to get the salary column and to get the mean value. This is how you can use it. If you also want to group by and doesn't want to sort, and then if you can also use the sort parameter here. We also covered this. You can also use operator to make a condition, the greater or equal, less or equal, or same. So you just need to make sure that these conditions is inside of this square bracket, and then make sure that you print out this data to see the filter data. Yes, and we covered this too, slicing. You can get a specific column, and then you can get you can select the rows using the index. This means 10 to 20. Make sure you can separate the start and end index using the column. And then we can also select the rows and then columns at the same time. If you wanna get the column using the index instead of their name, you can also do like this, like 0, 3, 4, 5. That's like a vertical index, like a 0, 1, 2, 3. You can also use in this way. And then we covered it too, getting first row and then nth row, and then make sure it's starting from 0. So when you say I, it actually get I plus 1 row. And you can also get the last row, or you can get the column. You can also sort the values. Also get some missing values and then see UCNAN. And in this data frame, that means the value is not specified. So you probably wanna remove those data because you cannot calculate it correctly, or you might wanna fill this data with something else because you cannot calculate this data with missing value, right? And these are all the functions we covered, method. We can also aggregate, use the aggregate function for min, max, count, sum. And this is how you use it. Get the specific columns and then aggregate the data for min and max. And then now you think of it, when you're looking at this table, do you think this data, it kind of makes sense to you? So maybe this is a delay time, depart delay, arrival delay. But mean value is a minus here, right? Usually when there is a delay, we use like 16 minutes delay or 100 minutes delay. But the max is 351 and mean is 9. But the smallest value is 16. This give you some idea, maybe your data set is not correct, or there's some like outliers value that you will have to remove. So understanding the data structure is really important because when you're working with the real data set, knowing the data and the calculating it correctly is really important. For example, let's say you submit the assignment and the computer miscalculate your grade and then you give a -100 or something. And then that's the error, right? And then how the system admin or someone's gonna figure out that you're getting the wrong score, right? Then they'll have to see your data and then making sure the score is not less than 0, and then making sure that there's no issue in the system, right? It's because all the data we are working with, human put the data in Excel sheet or some form of the data, and then they make a mistake, right? So it's very important to verify the data and then making sure this data is correct. We also covered this, and some graphics. So I added this line in the beginning. If you remember, there was the here, and then usually you don't need to add this line, but this is kind of key telling this notebook, okay, I want to visualize something and show this on this page, right? So this is like kind of rules to visualize data on this website. And if you are curious about how to use this, you can also hover your mouse on the matplotlib, and it's gonna say, okay, set up matplotlib library to work interactively, and then this is how you use it or something. And if you are curious about understanding this data, you can always do opening tab, and then they're gonna give you some information here, how you're gonna use it, why this is important, and then yeah, this is why we added this line at the first place. And then going back, there are like different graphics we can leverage, like this plot, bar plot, violin plot. This is look like violin, that's why, and the joint plot, pair plot, box plot, and then we can see how they look like, right? So let's create a sample data set. We just have 1, 3, 4, 5. Oh no, 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 not this one. Going down. Okay, here. Okay, we're gonna use a salary data set. Salary data set was here. So this is how the salary data look like. And then if you run, let's do one by one. Yeah, this is a histogram, look like a bar chart. So what you can see from here, we have like data between 90K maybe to 111K. They're like, this range is very popular because almost like more than 20 people fall into this range, right? So when you can see that, okay, actually they're not the same. Some specific range, we are seeing more data, so you can kind of think of, okay, I'm kind of curious what is the distribution in general, right? And then you can also do bar plot. Yeah, this is more like you want to see the data by rank, and then Y is going to be our salary, and then you can see, okay, professors have high salary, and the associate professor and assistant professor, and then maybe you can think of maybe in general like professors have high salary, but you never know because you don't know the data yet, right? So going to the violin plot. Does it look like violin to you? Um, um, do you think you can interpret this by looking at this chart? No? Is it complicated? So that it's kind of show you the groups, right? So this violin kind of like narrow. That means the data is just distributed very like widely, right? So all the data, you can think of the inside of this violin, there's a data is just distributed. So which means there is a big range of this data for the professors. But if you see assistant professors, the violin is more short and then like wider, right? That means the salary data range is smaller, but they're like kind of close to each other. So if the data is very like distributed like this widely, it's kind of hard because some of the data, like 200 or 5K data, can contribute a lot when you're getting the median or like average value. So for example, if you have a lot of data like this, there's a million or a billion, if you get average, it's going to be really, really high, right? So to know that before, it's really important to see the chart and then see, okay, this is how my data is distributed, right? And then scatter plot, it's just like a dot, like showing you where is your like each data point is located in this plane, two-dimensional plane, and then you can choose an X and Y also here. Also box plot. This is kind of similar, maybe can be similar to violin plot, but it's different because you see this here, this show you median value. So it show you that the median, the data in the middle is located this way. So if the bar in the middle, like line, if it's not, it's kind of tilted to the up or bottom, that means your data is kind of tilted to some like position. So you can think of a lot of like people are grouped in specific range all together. So it's like a seesaw. Like it's kind of like giving you which one has like higher weight or higher concentration um, among this data. So that's the box plot. And then if you wanna get the count for the each for the specific column, you can also get use the value underscore count. But if you see that, now you can see that professor data we have 46, assistant professor data we have 19, and associate professor data we have 13. So this kind of give some kind of suspicion that okay, why don't we have a lot of data for assistant professor or associate professors? If the data is too small, um, it's easy to misinterpret that the distribution because they're so small. So each of the data have a lot of power in the visualization, right? So when you run this KD plot, it's gonna give you all the distribution for per each rank. If you see here, the blue is a professor, their data distribution, and the assistant professor, this is a green, and then this is a orange color. And you can see that because professor has a lot of data, they might be more like a bell shape, and then kind of a middle salary data is very stable. It's like around 125 k. But if you see assistant professor and assist professor, the shape is very different, right? So it's hard to assume or conclude that um, we can say that okay, salary for the professor usually have a higher value or their value is higher than others because you don't have the same number of the data. And then if you see this graph, they're not stable. So in the data science, it's really important to look at each data, see the patterns, make sure you have enough data, not missing data, not tilted data, and then verify your conclusion is correct. So that's why we have to learn how to visualize our data and then interpret the data in a right way. So yeah, this is the end of the visualization, and I think we covered all the slides today. So I think this is end of the class today. So it was very long, so good job everyone. And then I highly recommend to run this code if you can, and then work with this data set and trying to get familiar with all these like functions. It's gonna be really helpful if you want to work with the data. Yeah.
Thank
Okay.
you.
Thank you. Also, I share the email, so feel free to reach out if you guys have any question. How can I access the code? So, did you get any link for the code, Ivan? No? Professor, did you share any links for the code and data set?
So actually, we have the lecture note.
Okay, okay.
So
They're in the
that is
lecture
the
note.
same depository, and you put your lecture note. Do you
Okay,
have any kind of the code and data set there?
lecture note.
Yeah, so your lecture note.
I hear this lecture note.
Yeah, yeah. So you put this lecture note in the depository, right? The shared folder.
Yeah, and with this, I put all of this together.
Yeah.
So
So student can see the lecture note and then they can see the code and then data set, right?
okay. And then they have a link, right, for the
Yes,
repository?
yeah, the K-Daily sent a link.
Oh, okay.
So the student, and did you receive the link? Are you checking the emails?
Um, I think they might not. They didn't check the emails. Oh yeah, Ray said he got it. So okay.
Yeah, so it's there then. Yeah.
Okay.
Yeah, please check, your email definitely, and then, and at the same time, you need to check the lecture note and then the materials. And
Okay.
it's extremely important, Well, you cannot learn, programming just watching. So definitely, and then you need to do by yourself, by your own hands. So please, check the, lecture notes and then see the code, and then you can just, repeat. All right?
Great.
Yep. So
Okay.
that is your homework. So please, review lecture note and then try to learn, yep, the code, by yourself. All right? Okay, good. All right, thank
Okay.
you everybody, and thank you, Emma.
Thank you.
All right, good night.
Good night.
Mhm.